Oh, this is not going to be a terribly technical talk, although I'm happy to dive into technical details if you ask. And there's a lot that I could talk about. I know the theme of the hackathon is around social justice, but also building stuff. Um, Instead of talking about just other people's work, I thought I'd spend a little bit of time telling you what I do when I'm not teaching and how it fits into a very interesting topic, which is the future of work and how technology affects work. So I hope you ask questions along the way. I have kind of four parts in this story about natural language processing and the future of work. The first part is just to talk about how technology and work kind of go together. The second is to talk about how that relates to social justice. Then I'll dive into the natural language processing part. And there was a fourth part. Well, let's stick with it. Oh, yeah, the fourth part is I figured I'd just like tell you a little bit about my story. And if you have questions about anything unrelated to the topic of the talk, but you just could ask me anything at the end if you want. So, and you know, we have a while to do this, so don't feel like you can't ask questions because you're slowing everything down. People can leave early if they want to. I won't be offended. And we'll just kind of take our time and work our way through. So, and I have a question already of how to use a particular technology. And that's kind of not what this talk is going to be about, but I can give you some pointers as we go about like how to get started on building stuff. But the talk won't be really about building stuff because there's, well, maybe I should say why. I'm not just going to tell you how to build some natural language processing system. There's pretty good tutorials out there already. And also, I think it's critical to figure out what to work on more than just how to build things. And you know, most of what you learn in school is about how to do something. But figuring out what's important, like what you build that's actually going to matter, is a really tough problem. And you know, spending years building something that doesn't get used or doesn't improve the world means that you didn't spend those years particularly well. So choosing a problem up front is really important. So I guess I will delay this question about CMU Sphinx for a while and dive in. And then if we have time at the end, maybe we'll talk about that. Okay, so technology and work, like how does it relate? Well, technology often improves productivity, which means people can get more work done every hour, or it takes less effort to get work done. So like if you're farming, then one use of technology was to help get animals to help you out, and then machines, and that made people much more productive. And now we have artificial intelligence to help us farm. So you don't need to have someone driving the tractor anymore. And I guess what we've seen in agriculture, at least as a fraction of the US labor force, is that to provide food for people in the country takes a lot fewer people than it used to. Back in 1870, half the population of the labor force was working on agriculture, on farming. By 1920, when they had invented the tractor and started using it more broadly, this was up to like 30%, down to like 30%, which meant that people could do other stuff than just grow food. And now it's just over 1% of the US labor force works on farming. For all of food production, so like all that manufacturing of food and stuff like that, it's larger. It's like 11%. But still, most people do something other than create food. And the reason is that technology has made people more productive, so it requires less effort in order to generate the food. Okay, so this has had major implications on what people do with their time, at least for their careers. And I think one of the most interesting ways you can look at this is to look over time, what's the most common job in each state. And this chart, which we'll animate in just a second, starts in 1978. And there were several states where the most common occupation was a farmer at that time. You can see that in many states, the most common occupation was a secretary. This is kind of before word processors and spell checkers, before email, and then some smattering of truck drivers and machine operators. Now, how did this change? Well, let's take a look. Oh, come on. Okay, I guess we have to leave this. You can still see, right? All right, someone nodded. Excellent. Let us animate. 1980, 1982. I can hit play. It'll go for me. So as time passes, there's like a shift. Secretary basically disappears. Farmer mostly disappears. The most common occupation in almost every state is truck driver. I guess until you move all the way to 2014, which is when this visualization was created. And then there's a couple of places where software developer is the most common occupation, but truck driver is still kind of everywhere. And that story that I showed you about agriculture, well, it also relates to transportation. So, horses were important for transporting the mail in the days of the Pony Express, but now machines are used to do that, cars and trucks. But people need to drive those trucks, although there's a lot of effort in creating self-driving trucks, which might change the productivity of truck drivers. If your car can drive itself all night, then you don't need to stop and sleep. You can just sleep in the truck as it drives for you. You might be able to get twice as far each day. Now, how terrible is this, that everybody has to switch jobs? Well, it turns out that not everybody's switching jobs. In fact, the set of people that worked in 1978 is a different set of people than were working in 2014. So it's not like all the secretaries had to learn how to become truck drivers and then had to become how to learn software, become software developers. Instead, there was kind of a shift in the population. And here you can see different generations over time and what fraction of the workforce are comprised of people in these different generations. So there's like a millennial generation, which is now the largest fraction in the United States. So millennials overtook the baby boomer generation in terms of having the most population in the country overall just in 2019. But they overtook the boomers in terms of the fraction of the labor force back in 2013 or 14 because baby boomers are retiring. So if technology changes how people spend their time, because people become much more productive at doing something, and therefore not as many people need to do it in order to get the work done. This could be extremely disruptive if it happens overnight. It can be less disruptive if it happens gradually, and as new people enter the workforce and other people retire, there's some shift in the set of jobs that are done. Oftentimes, you think of artificial intelligence as targeting particular industries like truck drivers, and certainly will have some impact there. But McKinsey, which is a very large consulting firm, has an institute that does kind of economic research. And they tried to study every industry and every job in every industry, or at least every job category, to figure out what fraction of people's work could be automatable over the next however many years. They kind of guessed maybe the next 30 years. Timelines are harder to predict. But they came up with this fact that, well, most jobs can't be fully automated. You can't replace a truck driver with a machine because the truck driver does more than drive the truck. It also helps unload and helps with logistics and stuff like that. But it found that they thought that for 60% of occupations, at least 30% of their work could be automatable, which means there's this potential for them to get more work done because part of their job will be automated. But that means that lots and lots of different occupations are going to be affected. Okay, what does this have to do with natural language processing? Well, what is natural language processing anyway? It's, you probably know, but it's trying to get computers to do useful stuff with natural languages like English and Chinese, manipulate text. This can have some interpretation or some generation. So you take some text and you want to know what it's about, or you might want to create some text. Translation is creating text. Now you have to figure out what you're translating, so you have to interpret it, but you also have to generate that text in another language. Did animals help? Machines, artificial intelligence. Here's the same story that we saw for farming. Well, it turns out animals don't speak natural language. That's what's special about humans. That's what separates us from the beasts. So there was no like productivity advantage from horses. But machines have already given a big productivity advantage to translators. And this was like back in the 80s. People built software that was basically like a word processor in order to help make sure that if you see the same sentence twice, you don't have to translate it twice. It just copies the translation that you used before, and includes spell checkers and other kinds of automated quality assurance. And this did increase translator productivity quite a bit. And then Google Translate came along. I used to work there. I wasn't there in the very early days of Google Translate when it first launched. I was there from 2010 to 2014. I think they had their first live system that they had built in-house in like 2007. So I was a little late to the party, but I was there when adoption of this technology was rapidly increasing. And by the time I left in 2014, I think 200 million people were using it every month. I mean, and it's only gone up from there. And then since I left 2015 to now, the quality of the translations that come out of a system like Google Translate has gone up a lot due to innovations in natural language processing, which are pretty interesting. So what happened to the translators? Well, it turns out average translator productivity has been fixed at about 440 words an hour for at least a decade, probably more. And it hasn't been affected at all by Google Translate. Why? Because almost all professional translation work in 2020 does not actually use Google Translate. Like even Google's team that localizes its text, like to publish an article in 20 languages, doesn't really use Google Translate very much. They've started to, like with some experiments, but that's been just the last couple of years. Basically, like human translation to achieve very high quality, the kind of stuff that you would want to publish, is still not something that artificial intelligence has reliably achieved. And you might think that translators are getting replaced by Google Translate. Well, it turns out that doesn't seem to be true. The professional translation and localization industry has been growing at a steady rate, and it doesn't seem to have changed much in the last 10 years in terms of the size of the industry and how it's growing, meaning that people are still doing as much like human-based translation as they were before this technology was really built and became good. And what I mean by became good is that since 2017, so in the last 3 years, the fluency of the text that comes out of Google Translate has gone from like poor in the sense that you could notice that it was a machine translation in every single sentence that you would read, to quite good in the sense that like you read the text that comes out of this thing and it's like, oh, that looks like something someone might have written. It's not perfect. Like it doesn't always describe what was in the source document correctly. You wouldn't want to translate the instructions for how to put together a piece of furniture because it might just like get some detail wrong and then you can't put the piece of furniture together. So, but certainly the text that comes out looks very fluent. So isn't this interesting that technology can have such a massive impact on how people spend their time, on their productivity, on their work? And yet what we've seen in natural language processing is like a massive advance in the quality of the technology and not much change in how professional translators work. And I think this is true across other domains, like the work of someone writing a book hasn't changed much due to natural language processing, or writing a news article, even though this technology seems like it's really related, like it can understand books and generate text and stuff like that. Okay, so that's part one, the relationship between technology and work. I talked for a while. I'm going to hang out, take a few questions about that, and then I'll dive into whether this has anything to do with social justice. That'll take just a couple minutes, and then we'll talk about natural language processing in more detail. Anyone want to pipe in at the moment? Oh, come on.
So I actually see a few questions on Mentimeter. So I can ask them directly from there if you would like.
Sure.
Okay, so the first one is, how did the quality of translation go up? How does it account for new slang in languages?
Yeah, so the way these systems work is that they are trained on examples of translation from the web, and content on the web, some of it's old, but more of it's new than it's old. Like people are writing stuff all the time and having professionals translate it all the time. So every time, big company like Google or Intel, or even like a more traditional company like Adidas or something like that, writes a document, whether it's like a customer support or a marketing piece or whatever, they'll have professionals translate it into many languages, post all that to the web. And then a system like Google Translate will acquire all of those different translations generated by people and train a translation system that's supposed to mimic the behavior of what a human would do. And so as long as like this new slang has appeared somewhere on the web in translation, then the system's going to learn how to use it. And they retrain the systems pretty regularly. So, I mean, the first time a phrase is used on the web, of course, it's not going to get learned because it takes a little while for the system to get retrained. But by the time you hear about some cool new slang, probably Google Translate's heard about it too.
Okay, cool. Another question is, did the McKinsey report study potentially replace replaceable work, like how AI translation has the potential to replace translators, or work that is ready to be replaced?
Yeah, so let's just stare at the chart for a second. I can remember how to use Google Slides. There it is. So the story is that if they looked across all occupations and the number of people in those occupations, and so I think this is measuring like total humans, they thought only 1% of them would be completely replaced by automation and technology, meaning exactly what they used to do is no longer necessary at all. Like they spent 100% of their time screwing in something, and now a robot can do that instead. Whereas how many people have at least 30% of their activities like be things that could be replaced by automation because the technology exists or should exist sometime soon, is a much larger fraction of the population. That's kind of what this chart says. So, so their analysis was that relatively few people would have their occupations disappear completely, but almost everybody would have their occupations changed in terms of like how they spend their time.
Okay, thanks. And then the last question I see here is, what speculation to text open source program is good for Spanish? She needs to use it for their startup.
You're looking for an open source natural language processing platform that can do something useful for Spanish.
And of Chilean descent, I guess. Or like.
Oh. So the systems that are built to process Spanish typically have some like mixture of dialects and lump them all together into Spanish, which is inappropriate, but also sometimes fine. So if you want to generate Spanish, then it's like really important that you know what region you're supposed to be generating Spanish for, because otherwise it will sound wrong, especially if you mix regions. As far as I know, the like open source systems that are available, Stanford builds one. There's one called Spacey that's used quite a bit as well. They don't distinguish. They just kind of pool all the Spanish text that they've trained on together. And therefore, you can't generate Chilean Spanish. What you could do is do a reasonable job of analyzing or classifying Chilean Spanish, because there are examples of Chilean Spanish in the data set. And therefore, if you use Chilean Spanish as the input, then the model's in a pretty good position to generate the appropriate output. If that doesn't work, then you're stuck with collecting examples yourself of the kind of thing you want to do. So if your goal is to like classify documents as like, you know, this is a patent and this is a news article or whatever, you'd have to collect some examples of that and train the open source software yourself on those examples. And these days, the nice thing is that you don't have to collect a lot of examples of anything. You can start with a base model that's trained generally on Spanish and customize it, or what we call fine tune it on particular examples of like some domain or some regional variant. And you wouldn't need like thousands of documents to get something reasonable to work.
Okay, thanks. That's all for, I guess, this round.
Okay, so what does productivity have to do with social justice? Well, the story is a little subtle, right? So what's social justice anyway? I think hopefully you've heard about this in other talks, since it's the kind of the theme of the boot camp. A big part of social justice is to make sure that people have equal opportunity, wealth, and power, like regardless of what family they were born into, what race they were born into, where they were born in the world. Productivity does something a little bit different, right? It helps someone do more with an hour of effort. And where does wealth fit in? Well, wealth describes what you can buy, what you can get other people to do for you, how much kind of economic influence an individual has. And a lot of people, like most people on the planet, are in the position of gaining wealth through labor or effort, as opposed to just owning stuff. There's like some people who own stuff, and therefore they don't have to work. They can just like accumulate more wealth through investing or something like that. But most people, they accumulate wealth through labor. And if they're more productive, then they can accumulate more wealth because they're kind of getting more stuff done every hour. And so if you could kind of like figure out a way to make everybody more productive, then you give everybody more opportunity. Does that make it more equal? Well, that really depends on kind of who benefits from the increase in productivity. So let me give you a quick example. It's one that I really like. And then we'll talk about what actually happens in the world and how just increasing productivity doesn't necessarily mean you're improving social justice, but there is an opportunity there for it to happen. So here's a picture of a guy reaching into a washing machine. That guy's name's Hans Rosling. He was a Swedish professor, passed away a few years ago, who was kind of like an early data scientist, I would say. He spent a lot of time analyzing the world through data and then trying to convince government leaders to change their policies based on what was actually observed in the world, as opposed to just like first principles of, oh, like taxes should be lower because people should be free to, because government should be small, or they should be higher because government should solve all problems. Like he just wanted to look at the data and say like, here's what actually is happening in the world and make decisions based on that. And one of his favorite topics was about what he called the magic washing machine. He often argued that the washing machine was the greatest invention of the Industrial Revolution because it basically just created free time. If you don't have a washing machine, you have to spend several hours every week washing clothes, and that's time that you can't spend doing something else. And that means that you kind of have limited opportunity and limited ability to create wealth because you have to just sit there and wash clothes. So the way he states it, I think is really nice. He said the first time they got a washing machine, he was 4 years old. And this is a quote from this TED Talk. Like, I would play it, but playing videos over Zoom is a disaster, so I'm just going to tell you. He said, "My mother explained the magic of this machine the very, very first day that we got it. She said, 'Now, Hans, we have loaded the laundry. The machine will make the work. And now we can go to the library, because this is the magic. You load the laundry, and what do you get out of the machine? You get books out of the machine, children's books, because now my mother had time to read to me. And we love this machine. We love this machine because this was," he said, like, "this is the start of my education, and why I became a professor is because we could go to the library while the machine washed our clothes for us." And so he concludes by saying, we really, really love this machine. My mother and me, we would say, thank you, industrialization. Thank you, steel mill. Thank you, power station. And thank you, chemical processing industry that gave us time to read books. So, the story there is something that improves productivity, meaning like reduces the time it takes to wash clothes for your family, can create wealth, can create the ability to spend time on other things. And so this is the kind of best case for productivity improvements turning into support for social justice or for increasing opportunity quite broadly. It's not targeted, but it is something that would affect people who really are time constrained because they can't hire somebody to wash their clothes for them. They'd have to do it themselves. It's not quite so simple, right? Like if you had to work an extra 6 hours a week to afford the rent on the washing machine, then you haven't gained anything at all. So people only benefit from this if what they have to pay is much less than the extra time that they get. And right now in the world, something like 2 billion people wash their clothes with a washing machine, and some much larger number, like 5 billion, don't. That statistic might be a little bit old. I think he gave this talk in 2013 or so, but not really, really old. So so anyway, so there's like a sense of inequality in the world that some people have to spend these several hours a week washing clothes by hand, and other people don't. I'm not claiming that all of social justice has to do with economics. Like police brutality is not an economic thing. Voter disenfranchisement is not economic. But a lot of what people experience in their daily lives does have to do with how much time they have to spend just to live and how much wealth they have in order to buy what they want. And so, if you have to wash your own clothes by hand, if you have to work 3 jobs in order to pay the rent, well, that limits your opportunity and your ability to create wealth and kind of live the life that you want. So in this sense, there is a relationship between productivity and social justice. And natural language processing, one of its bigger effects is going to be on productivity, I think, in the future. So that's why I'm talking about all this. But it's worth acknowledging that it's not like a clear causal path between increasing productivity of people and all of a sudden everybody's better off. It could happen that way. In the case of the washing machine, I think it really does, but it's not guaranteed. And in the sense that it's not guaranteed, you have to wonder who gets the benefit of that productivity. So productivity goes up, but do people's wages go up? Do they make more per hour? Or does all the benefit of the productivity go to whoever invented the technology? In that case, according to GDP, the same amount of wealth is created, but now all of a sudden, one person benefits, and it might be a person that has a lot of money already, or maybe the one founder and a couple of VCs and a couple of hedge funds. But their lives might not be materially changed by having yet another few $1 million. Whereas if people's wages go up by 20%, that can allow them to buy a washing machine, which frees up 5 hours a week, which means they can read to their kids. I mean, that's a real empowering benefit. So so what's actually happening in the world? Well, I guess the picture could certainly be rosier. So one interesting macro measurement of whether people are benefiting from increased productivity from technology is to look at whether wages are going up. So for all the people that accumulate wealth by working, are they accumulating more wealth because their wages are going up or not? And GDP goes up because of the increased productivity. More stuff is getting done, more stuff is getting built. That's the gross domestic product, a broad general measurement of everything that's produced by the country this is about the United States. But what we've seen, at least since 2000, is that wages as a fraction of GDP have gone down quite a bit. So while productivity has increased the gross domestic product, wages haven't increased much at all. And this is like a sharp trend in this 15-year period, but it's a pretty general downward slope over time, even back to 1950. And where else could the increase in GDP go? Well, it could go into corporate profits. There's been a spike in that recently. And so, corporate profits are what go to the owners of the companies as opposed to people that work. And this is not just in the United States. So labor's share of GDP has declined in 42 out of 59 countries when this report was written in 2015, including China, Mexico, and India. So these are just like very populous places. And so like advances in technology, especially information technology, so that's all the computing that is the focus of this hackathon, has made it kind of a better deal to invest in stuff and technology than to invest in labor. Extreme examples of this are companies that have like very few people working for them, but still have a big impact on the world, and therefore make a lot of money, but that money is very concentrated. So productivity increases can create new opportunities for people by increasing wages, but it doesn't always happen that way, and therefore productivity is not like a guaranteed path to more opportunity, more social justice. It's a potential, and it's a potential that's seems to not be totally realized in the world today. I think when you decide what to work on, whether it's natural language processing or something else, it's worth understanding a little bit about the structure of the world and how you might fit it. So that's the end of section 2. Figure I'll take a few questions, and then we'll dive into some natural language processing examples and try to tie all this together. Any questions?
Yes, hi, Professor DeNero. Yeah, so I think you made a very good point in pointing out that technology doesn't benefit everyone equally. So with regards to that, like especially in terms of technology that are quintessential to everyday life, such as the internet, do you think that the broader public have a responsibility in terms of providing such a technology in order to breach equality? And if so, which party should be responsible for such a providing this technology to breach this equality?
Yeah, it's a great question. I think we have very strong property rights in the United States, and the United States is not unique in this sense. Like if someone builds something, then they own it. But one person owning and controlling something isn't always in the best interest of everybody. If one person owns a national park and they get to walk around in it whenever they decide to go on vacation, but nobody else gets to go there, then it's not benefiting people as much as if lots of people get to go there. The internet is a really wonderful example of something that wasn't really a product of the free market system or capitalism or due to property rights. Instead, it was extremely collaborative in its creation. The technology was kind of funded by government grants, some of it built in government labs and then built out through university collaborations, and kind of set up to be open by design. People could participate in it. Individuals and companies alike. Like individuals can have access to all kinds of information. shoot. Can you, I'm hoping you can still hear me. It just told me my internet is unstable.
Yeah, right now.
We can hear you now.
Okay, cool.
Cut out for a little bit there.
That's a bummer. I'm sure I said something really clever. I was gonna say, like, the fact that the internet is open has benefited individuals a lot. It's also created lots of opportunities for companies to be created and to create new services. So I think you might wonder, whose responsibility is it to maintain that openness? I think if the goal of the government is to promote the common good, then it's certainly the government's role to do that, because the internet is the common good. Now, the role of government isn't just to promote the common good. You know, government is kind of accountable to the people in various complicated ways, and sometimes it has other goals, some of them much more nefarious than just promoting the common good. Some of it's, you know, I mean, wars are waged by governments, and those rarely promote the common good. So I guess my point is, if you want something like this to be open for the long term, then it usually takes some act or some effort. Government, like national government or collaboration of national governments, is a natural set of people to make that happen, but it doesn't always work out that way. I certainly hope it will in the case of the internet.
Another question we have, sorry, I'll go ahead.
Oh, I had a question. Like you said, unregulated increases in productivity just seems like it's going to result in a overworked middle class and like a rise or increasing gap in inequality or income inequality. So what do you think the future of the middle class is in terms of jobs or like legislation, like a universal basic income, things like that?
Yeah, good question. So, I mean, I would say increases in productivity are have the potential to kind of benefit everybody, because, like, you know, we wouldn't have the wonders of the world we have today if half the people had to spend their time farming just to feed us all. So productivity growth, you know, isn't naturally bad, I don't think, but what is really problematic for most people is if all the benefits of the increase in productivity, all the wealth that's created, is just concentrated in a few people who like own the technology in some way, or have figured out how to kind of channel the profits just to them. Because in this case, I guess two things happen. One is, while wealth is created, it's not distributed around, and so only a few people benefit. But second of all, you still get all the disruption from increases in productivity. So, like, you know, if it takes fewer people to get existing work done, then some of those people have to find something else to do. You know, if everybody was benefiting a lot from the increase in productivity, then this would be fine. There's would be enough wealth to go around. And I think in the modern world, there probably is enough wealth for everybody to have a washing machine and the power to operate it and the running water to operate it. You know, if we stopped building mega yachts and started just building washing machines, like, if we could crank out a few billion of them. But I guess the point of my long description here is to say that I don't think productivity is the problem. I think the policies or the economic structure that allocates the benefits of increases in productivity is probably what you'd want to change in order to make sure that society improves as a result of increases in productivity. And, you know, universal basic income is a perfectly reasonable proposal for doing that. It's a kind of simple and efficient wealth redistribution method. Like, I'm sure it has some side effects that are complicated. And so people who criticize universal basic income probably aren't totally off the wall when they say like, oh, does this change how people will spend their time, their motivation to get stuff done? Like probably in some ways, but it's certainly like better for everybody if folks can spend their time doing useful stuff, going to the library instead of washing their clothes, and some kind of wealth distribution system that gives many people the benefits of increase in productivity would be in a better position to achieve that than I think what we're seeing today.
Right, thank you.
Professor, with what you just, oh, sorry, go ahead.
Sorry, I was just gonna ask if there's still time for another question.
Sure.
Okay, so I'm wondering, I was kind of interested in this quote that you pulled up on the slide, which shows, it says near the end, companies shifted investment away from labor and toward capital. And I'm wondering in terms of like why investment might be shifted away on that edge, people thinking if we make companies stronger, then I don't know, the country as a whole gets stronger. And then that made me think, do you think like investing away from open access, so keeping things kind of private for your own country, like it into international competitiveness? So in the news a lot today, we hear about like, like actions by the current administration regarding like the Chinese, I forgot the word for it, like accusations of Chinese intellectual theft, and how that might influence why we keep things open access or not.
Yeah, look, there's a lot of trade-offs. So competition has some benefits and has some drawbacks. There's things that are much better when they're done cooperatively. Internet is a good example. And there are things where competition really helps a lot. Like, a monopoly can actually be bad for consumers because the monopoly can charge as much as they want. And so that's why like power companies are regulated, because it doesn't make sense to have 8 different power companies in Berkeley, or at least it didn't before we had alternative energy that was less capital intensive. And yet, like, you don't want to have the power company be able to charge you the maximum amount that they can squeeze out of you, or everybody would be paying a lot for their electricity and couldn't do anything else with their money. That would be bad. So, so trade-offs exist in many cases. Certainly with intellectual property, it's full of trade-offs. I mean, the intellectual property laws in the United States trace all the way back to the Constitution. And the goal there was to make sure that people didn't have trade secrets, but instead would publish their inventions as patents so that like it may in fact encourage innovation if hopefully you can
hear you.
Maybe I'm back. It can in fact encourage innovation to protect intellectual property. But then again, like if some technology is invented
Okay, got you back now.
You're muted though, Professor.
Well, that was sad. I must have answered your question right when I got cut off. No, I hope I kind of answered your question in saying that things are complicated. And sorry, I got dropped.
You cut in and out, but thank you anyways.
Oh, too bad.
Do we have time for one last question, or are we short on time right now?
One more.
Okay, thank you so much. So I had a question in response to, or sorry, I had a question about one of the responses that you gave previously, where you mentioned that we shouldn't be concerned as much with productivity that we should be with social policies. So it seems from that response that the power is really in the hands of policy creators rather than startup owners or people who are inventing technologies. I'm wondering what sort of considerations computer scientists or people who are creating these technologies should take into consideration. Ooh.
Hey everyone, so it looks like Professor, oh, he's back. Professor, you're here, but we can't hear you right now. I'm not sure if you can hear me. Maybe you can try turning off your video. That could help with the connection.
Sorry, we don't have Jeopardy music.
Hopefully his internet will come back soon.
Meanwhile, this is a great time to advertise our upcoming workshop at about 9 p.m. We have a PlexTech recruiting workshop hosted by Rithvik Agastya. Yeah, so while we're waiting for Professor John DeNero to come back, one thing that is good for y'all to know is that Professor DeNero actually teaches CS61A, which is Berkeley's intro computer science course. I think all of our executives have taken CS61A, and we're also obviously Berkeley students. So if anyone has like a Berkeley question or anything like that, I guess this is a good time to ask now. I think one question that we have here in the Menti is where/how does Berkeley study the intersection of tech and social justice? That's a good question. Our hackathon is centered around the theme of tech and social justice. Berkeley does have a course on this. It's taught by actually CS61B's professor, Josh Hug. And Josh Hug teaches CS195, which is the social implications of technology or something like that. But if you look it up, Berkeley CS195, you should see it there. And that's a really great course. It teaches you how like these companies that are here today. Oh, John's back. Hey, hi, Professor. Hi, Professor. We're filling in some time by talking about CS61A a little bit.
People are still here. This is amazing. You must have done a great job filling in time.
Yeah.
Nicely done. Nicely done. I changed rooms. That might change my internet quality.
Awesome. We can try turning off videos. That might help.
I'm so sorry.
That's okay. So CS195 is a great course. You should definitely check it out. Okay, we have another question here in the chat. Do you know what general club activities will look like this year? That's a great question. Thank you, Kevin. So general club activities, we have, actually, Pranay, do you want to take this one? I've been talking a lot.
Yeah, sure. So general club activities will be hosting workshops, and it's basically going to be like an extension of the workshops we have now. So like we'll try to contact more industry representatives and get them to speak about random topics throughout the year, such as we can go, if like the PM panel and the game dev panel goes well, we can find more representatives for that. And we'll definitely look to like everyone else's suggestions to see like whatever panels you guys want and whatever industry workshop representatives you guys want to hear from, we'll definitely try our best to push it out to you. And we just want to make sure like everyone knows that all these events are going to be open, at least like these workshops, because we really want to push that like we let people like have these opportunities to meet with everyone, like Professor DeNero and everyone else. And it seems like
You muted.
I think he muted himself. I was just gonna say, oh, no, never mind. There we
Oh,
go.
is he here?
Yay.
We're gonna. I'm so sorry, folks. Now I'm using my phone's internet, so maybe that'll be better.
It's all good.
TLDR on that question, which was companies can decide how their technology is deployed, and they don't necessarily just have to kind of collect all the benefits for themselves. It's very common that they try to benefit other stakeholders as well. Nothing wrong with that. It usually happens because employees of that company ask for it. And so if you go work for some big tech company, make sure you advocate for the company to do something useful. Don't just leave it up to the regulators and policymakers. Okay, I'm going to dive into this part of natural language processing because I think I put that in my title. And so here we go. I'm still here, just sharing my screen. So what's going on in the world of natural language processing? Well, big things are happening in the technology part. I think it's the most exciting time that I've seen since I started working in the field in 2005 in terms of how fast systems are getting better and how clear the path is to like getting traction on problems that have been difficult to make progress on for a long, long time. This is largely due to this idea of a neural network, which is a particular approach to machine learning. Machine learning is basically learning to mimic some process by observing many examples. And the applications of this technology to natural language is to build what's called a language model. And a language model is a neural network that looks at part of a sentence, like an unfinished sentence, and tries to guess what word is going to come next. So you were probably able to guess that the next word was next. That's because you as humans have a very good language model. And, you know, language models look at what's been said so far and try to guess what was written next. You can't always guess exactly what's written next because, you know, people say different things. There's like creativity in content and language use. But you can make reasonable guesses in some contexts about what will come next. And language models attempt to do just that. Tons of really exciting technical work in this area over the last few years. The big, I'd say the application where most of the details of this technology was worked out was actually translation. So fully automatic machine translation was where the architecture of the neural network that's now used for language modeling and basically all other natural language processing models came from. It was kind of invented for translation, but it works well for lots of other tasks, including language modeling, which is basically for a sentence or a document, guess the next word. So when you're training a neural network, you give it a bunch of examples and you tell it what objective it's supposed to achieve. Here, the objective for a neural language model is to correctly predict the next word in a web page, given that you've observed most of the web page so far. And you show it 1.5 billion you show it 8 million web pages. You give it a lot of numbers to adjust, making these predictions. And what's cool is that you can predict more than just one word. You can have the output of the language model generate the whole rest of the website or web page by providing it as input some prefix, having it guess the next word, and then using that output as the next input. So you'd ask them, so if you can predict the next word, you can ask it to predict the next word over and over and over again. Here, now, it's not conditioning on what you told it to say, but on its own output. But it's also conditioning on however you set it up. And that means that the language model can kind of continue generating a piece of text that you start. Let's try it out. Is what this language model thinks it is. So what this is AI into I don't know if you can hear me anymore. Doesn't look good. Oh, it worked.
We can hear you.
Okay, you can hear me, and it worked. So I said, write me a web page that starts with social justice. This isn't come up with social justice. This is not a utopian ideology.
Okay, we can't hear him.
I think he's out of the call again. Or he's still here. It's
Yeah, I'm back.
Okay.
My screen share is probably gone. Try again.
Yeah.
Well, someone's got to make me a host.
Oh. Hold on. There you go.
Since this model could complete any web page, we could have it say, I have 2 cupcakes and I get another 2 cupcakes. So now I have what would be a reasonable completion of this? A stomachache. Okay. So it's decided that this is like a quote from someone named Garrett Gasta. So if you like let it keep generating, then it will come up with the fact that Garrett Gasta said this on February 18th, 2015, which maybe they did or maybe they didn't. The power of the language model is that it can generate text that looks like it might have actually been written by somebody or appeared on some web page somewhere. But some of it's a little bit incoherent. I don't know what this has to do with cupcakes. What else could we ask this to do? We could ask it when my package is arriving. Package is arriving on time. Sorry for the inconvenience, says the United States Postal Service. Package. Your new printer will arrive on the 1st of the month within 2 to 3 days of working time. If you can't wait that long, you can always pick it from our next available class. Okay. So this is kind of like close to the state of the art. There's now a slightly larger model that OpenAI has built. But a system that can produce language based on some prefix that seems coherent. And we couldn't do this before. It looked like nonsense before when we tried to do this, and now it looks like something that might appear on a website. It isn't based on any facts. Like, I am getting a new printer, but it's coming tomorrow. It's not coming on the 1st of the month. And so, like, it hasn't queried some database to figure this out. It's really just looked at all the 8 million web pages that it was and figured out what words might come next. Now, people are really excited about this technology. Why? Because it turns out if you train 1.5 billion parameters on 8 million web pages in order to predict what comes next, you can then repurpose that model to do all kinds of interesting inference. A language model can be repurposed to perform, for example, text classification. And the quality of text classification systems is much higher now than it used to be a few years ago, because we start with a language model that actually works well, and then we kind of tweak its parameters by adding another layer on top and a few examples in order to get it to do something new, like take in the text of an email and tell us whether it's spam or whether it's something that we'd actually want to read. So in this picture, I've given you a couple of links. I'll share these slides with you later. This picture shows Bert from Sesame Street instead of a language model, because the best way to do this doesn't actually involve predicting the next word, like from left to right in a sentence, like I talked about. Instead, it involves taking a sentence, covering up some words, and trying to guess what you covered up, which is just slightly different than guessing the next word. But the model architecture is the same, the way you train it is the same. So it's basically taking a language model and turning it into a model for some other task where it can help interpret text. Whatever you tell it as input and give it some examples, it can figure out what's spam and what's not. It can figure out what's a well-formed sentence and what's not. It can figure out whether a sentence is implied by a previous sentence or whether they're unrelated. Stuff like that. And mostly these are tasks that humans don't really do today. Deciding whether a post on Facebook is hate speech mostly isn't done by people. Ranking which web page is most related to a search query mostly isn't done by people. So this technology, while it's exciting for lots of technology companies, hasn't kind of directly replaced human labor. It's instead enabled automated systems to do things well that they used to do poorly. Stop for a second, see if I've lost everybody. You want me to talk about how these models work?
You're good.
or something like that.
Hi, Professor. I have a question. In
Uh-huh.
This is more in general with AI, but since like recently quantum computing has been used with AI, do you think that it could be used for natural language processors as well, or is it being used currently?
It's not being used currently, you know, most of the results in quantum computing are still theoretical. There aren't really quantum computers that are doing useful stuff out there in the world that conventional computers aren't doing. Oh, that's very funny. My printer actually just arrived and my wife put it on the table. The issue with quantum computing is that it's difficult to get it to do exactly what you want. So there's a lot of theoretical work just to figure out how to achieve things that we already know how to do with a conventional computer. And as far as I know, no one's really come up with exactly how quantum computing would help with training a large neural network. So right now they're separate fields. People have speculated about how they might merge, but they haven't really like had some big synergy yet.
Okay, thank you.
Hello. I don't know if you can hear me.
I can hear you.
Okay, so I have a question. How is this model and this neural network, and how can this language model apply to like daily application?
Yeah, good question. And this is really an open question. How do you actually do something that's going to improve your life using this language model? Well, it turns out in this picture I'm showing you right now, where you can get the language model to do any kind of text processing task, that it's led to big improvements in, for example, search ranking, where you make a Google search and it guesses like which web page you're going to want to click on. By using the contents of that web page and pushing it through a model like this, you get a large improvement in the accuracy of the ranking, meaning the top results are things that people actually want to click on. You know, Facebook does run an automatic filter for removing hate speech from the platform model, and hopefully you can hear me. And, you know, that does affect how the platform works because it's like reasonably accurate in a way that it wasn't before. And that means that there are certain things you can't post on Facebook that are kind of removed automatically. Does it change your daily life in the sense of like you have a different experience going to the store? I'd say not yet. I'd also say that biggest application that people work on is smart assistants. So like Siri and Alexa and stuff like that. And their responses are not generated from a language model in the way that we just looked at. Instead, they're mostly scripted. Like someone's decided that when it presents the weather, it's going to present it according to this particular template that says, like, don't forget your jacket today. Like a human just wrote that and put it in as a rule in the system. And so the role of this technology is more about kind of choosing among those rules and interpreting the human response to figure out whether they're asking about the weather or they're asking about something else. And so it helps with that kind of application, but it's not like this technology is the backbone of these smart assistants. In fact, a lot of them are built kind of by hand, I would say.
I guess if I have a question, it might be like besides like what you mentioned like already about detecting hate speech, and maybe also other things like I guess like improving caption systems for deaf and hard of hearing folks, and like improving accessibility and stuff. How does this like how does this connect with social justice in general?
Okay, so here's the big one, is that when you're writing text, this kind of system can actually help if its job is to make suggestions. So here's where I think the connection is going to be. It's still like really early days. You know, this stuff, people get excited about translate the world in the sense that people use it a lot, but it's not good enough for publishing stuff. It's just good enough for reading the web. But human in the loop text generation can be good enough for publishing stuff. And what do I mean by that? Well, that means a person is doing whatever work they would do, like they're writing an email or writing a document. And the model is guessing what they'll type next. And this is a feature that's live today in Gmail called Smart Compose. It waits until it notices a context where it's pretty sure what you're going to type next, and then gives you the option to hit tab instead of typing it out. This can be an increase in productivity in the sense that you can get your email written faster. So Google's now launched this across Gmail and Google Docs, which probably means that they ran a user study to show that this really does improve productivity and it's not annoying. I'm working on a very similar thing in the context of translation. So instead of trying to replace translators with automated machine translation, we're trying to use this same kind of model. Here it's a translation model instead of a language model. So it actually looks at what's being translated, which means it makes better guesses about what's being written. Presents the user with a text editor and says, what do you want to type? But we guess what they're going to type. And if it turns out that we guess right, kind of like in Smart Compose, if it guesses right, then it can speed you up. Same thing with a professional translator. If we guess right, then it speeds them up because they can just hit tab and accept the next phrase instead of having to type it out. And if it's, I think the potential for increasing productivity is actually quite a bit higher in the translation case, because translators spend a lot of time trying to think of like, what's the right way to express this thing in English that was originally in Spanish. So they work much more slowly than at typing speed because they have to think a lot. But if the system can make a suggestion for them and it happens to be reasonable, then they don't have to think of the right way to express this thing. They can just accept the suggestion. And you know, this is today, you know, Lilt is a startup that I've helped co-found a few years ago, and we're building this kind of technology. It's a way to increase the productivity of translators using the technology by not trying to replace them, but instead just trying to make them kind of faster at getting the job done that they're trying to get done. And so I do think this is a case in which natural language processing can affect human productivity on a pretty broad scale. There's a lot of translators, and this can speed them up a lot. There's a whole lot of people writing email, and whether Google Smart Compose really speeds them up a lot or not, I don't really know. But my guess is that as the technology gets better and better, it really will be a part of how you write documents, is that you rely more and more on the grammar checker and the autocomplete than you did before. So that means that there's a way in which natural language processing might affect productivity. What does that have to do with social justice? Like I said, like the relationship between productivity and social justice is a complicated one, and it's not just like a simple causal chain. It can go either way. It really depends on who benefits from the increase in productivity. It does have the potential to improve people's lives. Like my colleague and I started this company. He runs it. I just do a little bit of technology on the side because I have to teach classes and stuff like that. But at Lilt, where we're basically building AI to help translators translate faster, here's what we would like to see happen, is that translators actually make more money per hour because they get more done each hour or each day. And at the same time, more content is translated correctly because translation is cheaper. Now, how is it that they can get paid more and the translation is cheaper? Well, because they're more productive. So it could be the case that the buyers of translation and the providers, the translators, both benefit from this extra productivity. And if more content is translated, well, that actually has follow-on benefits to the world. More people get to read what they want in the language of their choice. So like if a company only translates their stuff into 8 languages, then people who don't speak those 8 languages have to run the thing through Google Translate, which is always a little bit wrong. And that is like problematic. So, you know, people around the world really can be limited by the languages they speak in terms of what opportunities they have, what they can buy, what's available to them, what they can understand based on, you know, whether it's been translated correctly. So I think if more content gets translated correctly and more people get to read what they want in the language that they understand well, then it might be the case that in the future, a person's first language has less influence on their wealth and opportunity, which is a real social justice issue. I mean, the language you speak is not something that you get to choose. It's often where you're born, and it has a massive effect on your opportunities for gaining wealth and power and leading a healthy and comfortable life. So, you know, it's a pretty long chain to go from boosting translator speed to the social justice impact. I feel like as a company, if we want to see that happen, we have to think about each step along the way. So, you know, we build the technology, but we also work with translators to make sure that they're getting some benefit from it. And, you know, we're in touch with our translators, and, you know, we really strive to make sure they make more money with us than they do elsewhere. We also try to make sure that when a company uses us, they don't just translate the same amount of stuff for less, but instead translate more content with a fixed budget. So they spend the same amount of money, but they get to cover more languages. And we try hard to make the case that this is what they should do with their budget, is they should, you know, spend the same amount of money, but translate into more languages so that more people get to read what they want to read in their language of choice. And then, you know, do we have direct control over whether someone's first language has influence on their wealth and opportunity? Well, that's hard to achieve, but certainly we can try to make progress on the third bullet point by encouraging our customers to take the second bullet point seriously. So that's my story for how working on technology that increases productivity can hopefully actually improves people's lives, both the people that are becoming more productive and the people that benefit from their work, and everybody else that reads the stuff that gets published. Whether we'll get all that done, it remains to be seen. You know, this is an early stage start, but this is the kind of thing that I think natural language processing has the potential to achieve if you Okay, so that's kind of what I came here to say. I figured it would take less time, but it took a while, which was great. Well, I have more time to answer questions if you want. Go for it.
Do we have time for a question?
Sure.
Okay, so earlier you showed on your screen one model that was called GPT-2, and you know, recently there's been an even bigger one called GPT-3 that was put out by OpenAI, and it's much bigger, has like 100 and something billion parameters, which is like way more than the other one. But something that people have been saying is a problem with it is that it makes a lot of similar mistakes. Even though it's much bigger, it still has like all these tendencies to produce gibberish at random points. And so it's not really any closer to maybe like something that's actually like a really smart language model. So do you think like GPT-3 or 2 being that big, do you think it's useful as it is, or is there like a need for better research and like a whole new architecture in order to really be useful as a model?
For next generation, no one who's currently a writer today is going to get displaced by GPT-3. because we don't really have a way to make it talk about a particular piece of content correctly, like relay a particular set of facts. Instead, if you sample from it, it's about whatever it feels like. And that's not useful. It's cool, but it's not useful. The way in which these things are getting used is for other tasks, like spam classification, search ranking, filtering hate speech, kind of stuff. And in that case, the very large models do have increased performance on these fully automated tasks. So I don't think fully automated text generation is going to happen anytime soon. Like, I don't think we're going to replace translators. I don't think we're going to replace writers, news authors, something like that. In like very narrow domains, sometimes this happens. Like you have a 200-word company description and you also want a 100-word company description. Maybe you could automate that. But for the most part, like, writing is still going to involve human driving the process. And the use of the language model might be to speed them up as opposed to replacing them. And then in that sense, the one with the more parameters guesses right more often, and so it is a little bit more useful.
Okay, thank you.
Hi,
But
Professor.
no doubt, based on like how fast things have improved over the last 5 years, when I give this talk again next year, probably there will be a different architecture in place due to like interesting new research. So yes, there's a lot more to be done to figure out how to build these things correctly.
Can I ask a question?
Sure, sorry to cut you.
Oh, no, it's good. Yeah, so I was wondering, based on your work with Lilt, and I know you said it's going to take, a long time for anything to be fully replaced, but I was just wondering, do you ever see the potential for like a in-person translation happening? Like, if someone's talking in one language, do you ever see, like, maybe like way off in the future, would it be possible to in-person live translate it back to another language? Or is that something that's, too many barriers?
No, this is something that people actually use today. Like, it exists in the Google Translate mobile app that you can do real-time interpretation. And it's not right. I mean, if you say simple stuff, then it's probably going to be right. If you have like an interesting conversation, then it's going to be pretty hard to use. And yet people use it already today because there's no way they're going to pay for an interpreter and they really want to talk to somebody and they're willing to tolerate the mistakes. So in that sense, I think that right now, and certainly in the near future, real-time communication with someone who doesn't speak your language is possible. It's just a little bit painful, and that like level of irritation and therefore the sophistication of the conversation you can have will improve over time. But I'd be very surprised if it got so good that no one was hiring interpreters anymore. I just think we don't have a path to that goal of like human level translation and interpretation. And so, the United Nations is still going to hire a bunch of interpreters. And the best we can hope to do is try to help them do their job more efficiently. It's like exhausting work. It's very hard to get everything right that somebody says in some government proceeding, and good software to support people who are doing that would be welcomed by them, I think. So that's kind of the target for the professional world. Like the human in the loop work is to help professionals be better at their job. And then for the more consumer oriented stuff where people are willing to tolerate errors and mistakes, and if they have to say something 4 times, well, then they'll just do it because they don't have an alternative. Well, that kind of exists today.
Thank you.
Can I ask a question?
Go for it.
Okay, so Google introduced technology called Google Duplex, which basically allows for real-time calling responses and automated calls. do you, and I know you said that natural language processing and natural language understanding is probably not the best way to go in order to replace like, but more of like suggestions. So do you think something like this for using natural language processing for automated calls would be effective, especially from Google Duplex?
Yeah, so I'd say one place this technology is probably having a big impact today is for like text-based support. And Google Duplex is kind of similar to this. It's conversations that are highly repetitive. You know, people ask the same questions and the answers are the same, or they go through the same process. You know, when you make a restaurant reservation, it's like a very similar conversation over and over again. And that's where these models do the best. And like, this is the repetitive kind of work that everyone would be delighted if it went away. So if one person can handle 10 chat customer sessions at the same time instead of one, because like the system is automating some of the interaction, well, then that person is more productive. If someone who's like taking reservations at a restaurant can handle more calls at the same time, without always putting someone on hold, because somehow like a system like Google Duplex is helping support them. Or if an individual needs to get something done with a business and they use Google Duplex to do it for them so that they don't have to do it, it is a little bit like the washing machine. It is a way to increase productivity, and that certainly has the potential to benefit lots of people. Whether Google Duplex like really works reliably, I actually don't know.
So you're saying that from a conversationalist standpoint, the natural language processing would be effective. And I think that's what you were saying earlier. Am I correct?
If you have like what we call a closed domain, so like you really only talk about the same few things. Examples are airline reservations, restaurant reservations, asking questions about the geography of the United States, something like that. These systems can be extremely accurate if you give them a bunch of examples that basically cover everything that somebody might say.
Okay, yeah, thank you.
All right, guys, so it looks like it's past 9 o'clock now. I just wanted to give a big thank you to Professor DeNero for coming out and speaking with us, and all of you for staying even through the Zoom difficulties. I guess it's definitely a downside to everything being virtual, but yeah, thank you all so much for coming. And right now we have our PlexTech information session, tips and tricks for interviews. So if you'd like to head over to that, that would be awesome. Thank you again, Professor, so much.
Sure, it was a pleasure, and great talking to all of you. Have a good night.